Hey everyone, today we are going to discuss on AI tool designed to perform the data discovery against metadata. This tool will help to identify the data lineage and assess the impact on metadata for upstream and downstream applications. I would like to bring a few scenarios to illustrate the need for this utility. Scenario 1, if the physical field names hasn't undergone proper data modeling, then the field names are not clearly understandable. That makes data analysis very difficult. Scenario 2, if the product owner receives a requirement, a particular field name will undergo changes. The product owner, example, ICD-9 code is going to be replaced with ICD-10 code. As we know that ICD-9 and ICD-10 code differs in length, the product owner needs to identify which table, application, and downstream systems are impacted due to this change. Scenario 4. Nowadays, the natural language queries are very popular. If the physical file names are having undergone proper data modeling, then the natural language queries also will yield worst results. This particular AI tool identify the data discovery about metadata, data lineage, and identify the impact on downstream and upstream systems. This is the overall architecture about this particular tool. The first section is a user interface where the user enter their queries in natural language. That natural language query is fed into LLM, SAT-GPT models. The SAT-GPT model convert this natural language query into targetable fields. Take an example. In this example, if you look the natural language query, it was misspelled. Since we are feeding into LLM, natural language query has been understood by LLM and it convert into the targetable fields. These targetable fields searched against the knowledge base, which was the metadata repository, which was built based on logical name, description, physical name, and several metadata attributes. These targetable fields search against this knowledge base and identify the logical description, name, physical column name, and other metadata attributes. And apart from that, identify the relationships using the graph. All these informations now fed into LLM. LLM will consolidate all the answers and provide the natural language response to the users. The knowledge base and the knowledge graph needs to be pre-built before this application goes live. As part of the data modeling, we create logical name, description, physical column name, data type, and several other metadata attributes. All this information needs to be stored in the table in the knowledge base. Even if you store all these field names, you can't search field values based on similarity search because the traditional databases it look for the actual values or partial values. So you need to store the data which we can perform a similarity search. One good option is we can convert all these values into embedding. Once you convert these values into embedding, you can search against the natural language against those values. Take an example, cust underscore first underscore name. If you look for this particular field value in the traditional database, if the field value is not found, it will return the result that the field value is not found. But in a similarity search, if you look for cust underscore first underscore name, even though the field name is not found, If there is an existing field, individual underscore first underscore name, that field value will be written as a result. So knowledge graph needs to be pre-built using the primary key, foreign key, semantic similarity between the two attributes and the entities. That needs to be reviewed by the SME to make sure the knowledge graph is built on a correct model, built as a perfect source. So I'll again walk through that user journey. User enter the query, that convert natural language query, the natural language query convert into chat GPT model, chat GPT will convert into targetable field, the targetable field searched against knowledge base, and based on that result, it will identify the knowledge graph, all this information fed into LLM, and LLM provide the right answer. If the user is satisfied with the question answer, based on the response, it will be stored in the cache layer and permanent memory so that all the future queries will be redirected into permanent memory. But there will be a cross validation done that is there any other changes also done.